In topic 3 of chapter 7, there it is up there, we're going to be multiplying radical expressions. So let's go over some of the basic rules. Now, as long as the index number is the same, theoretically we can just put this under a common radical sign. So this just becomes the square root of 14. And this under a common radical sign, I don't know if you recognize that. These are conjugates, so you end up with x squared minus 4. That's what this is. And here it'll be the third root, same index number, so this is 45. And again, same index number. This becomes 18a and 5b. So this is sort of the easy part. If the index number is the same, you just multiply the radicands and there's your answers. Okay. Now here we want to simplify. And a strategy for doing it, this is how I would recommend that you do it. You want to simplify this by undoing what might have been there. And I usually put two sets of radical signs, because under this first set, you want to see if there's any factor of 98 that's a perfect square. So if you divide it by 2, you get 49, which is a perfect square. And the other part, the other factor is 2. Remember, we did this above and got that. Now we can undo it, but under that first radical sign, you want to see if there are any perfect square factors. So this just then becomes 7, the square root of 2. And if you could remember that, this will always simplify to 7, the square root of 2. But that's how we did it. So again, you want to use two sets of radical signs. And as you look at the number, is there a perfect square factor of 8? Yes, 4. So you put the 4 there, and then the part that's not, you put over here. Now, is x a perfect square? No, so you put the x over there. Now, in y to the third, is there a perfect square factor? And it's y to the second. So that's a perfect square. So what's left over? Well, a y here. So now you actually take the square root of that and get 2y. And then this is the square root of 2xy. Now, sometimes they want you to put absolute values here, but I will pass that up for now. Okay, so here we have this. And I looked at this before and I said, well, how can we figure out what would be the perfect fifth factor of this? Well, if we did this, 96 divided by 2 is 48. Divided by 2 is 24. Divided by 2 is 12. Divided by 2 is 6. Divided by 2 is 3. So we now have 1, 2, 3, 4, 5. 5 2's. What is 2 to the 5th? Well, 2 to the 5th are you thinking about it? Is 32 times 3. And we can make this one negative. So this is a perfect fifth, and we are allowed to have a negative when our index number is odd. So this becomes negative 2, the fifth root of 3 is our answer for letter C. And this was the technique I used to find out what would have been a perfect fifth factor. All right, as we look at D, D gets a little challenging. So let me do it down here. I'm going to factor this. I'm going to take out a 2x, and then I get x to the second plus 6x plus 9. And I say, oh, look what I found here, a perfect square trinomial. So I'm going to put this first in this form, x plus 3, the quantity squared, and that's going to be under one radical sign. And then I'm going to have times, under the other radical sign, 2x. So what is this? Well, I take the square root of this, anything to the same index number, this just becomes x plus 3, the square root of 2x. And I see they want you to put that in absolute value sign down below. Okay, so it looked a little daunting initially, and they're just saying this is what they want you to do, what you were doing up here, but in function notation. So now they want you to simplify. Well, I would do it this way. Again, using that same technique. Put your perfect square factors under this radical sign, and what's ever left, put over here. So a to the 10th is a perfect square, anything even. B to the 8th is a perfect square with a B left over. C to the 14th, I'm running out of room a little bit, with a C left over. So this is the 14th here. So we just now divide these by 2, get A to the 5th, B to the 4th, C to the 7th, and then this is not a parenthesis but a radical sign, the square root of BC. Again, you're looking for a strategy to do it. And I think a good strategy is under one radical sign, you put your perfect squares. And then what's ever left, then you take the square root. Now here what we want to do is put perfect cubes under one, and then whatever is left. Well, if I divide this by 2, I get 27. And 27 is a perfect cube. What's the perfect cube here? X to the 8th. Well, x to the 6th, anything that are multiples of 3, and then what's left goes there. Y to the 9th is a perfect cube because it's multiples of 3. And then we get z to the 9th, and there's a z left over. So cube root of that is 3. Divide this by 2, x to the 2nd. Divide this by 3, y to the 3rd, z to the 3rd, and then the cube root of what's left over, 2x squared c. So once again, the pattern is to put two radical signs with your index number, and then under the first one, put those that are perfect cubes. And then whatever's left over, you put there. Then you take the cube root of these perfect cubes and get your answer. Now, let's raise it up so you can see the answers here a little bit too. Just about. Yeah, there they are. Now, a couple of ways to do it. And the way I started off when I did it was, what are the factors of 6? Well, 2 times 3. What are the factors of 10? Well, 2 times 5. Can you see here a 4, which is a perfect square, and then whatever's left is the square root of 15. What is the square root of 4? 2. 2, the square root of 15. Now this would have been the square root of 60, and 4 times 15 is 60. This is just another way to possibly do it. And here we have a 5 times 2 times the cube root of 6 times 6 times 6. What is that? 6 to the third. What's the cube root of 6 to the third? Well, it's 6. So this is going to be 10 times 6 is 60. So we're using this little strategy here. If we didn't know what that was, this is 6 times 6. That's 36. And there's another 6. So this is the, whatever big number it is 6 to the third. And the cube root of 6 to the third is 6. 10 times 6 is 60. And here we have the fourth root, and it's 81, x to the third, y to the 13th. Now, 81 is a perfect fourth, so under this radical sign, you're going to put the 81, and then the other radical sign, nothing left over there. X to the third, is that a perfect fourth? No, so it's going over here. Now in y to the 13th, anything that is a multiple of 4 will be a perfect fourth. So that's going to be 12. And what's left over? A y. The fourth root of 81 is 3. Y to the 12th, this divided by 4 is y to the third. And then the fourth root of x to the third y. And I believe that's what they have there. Yes. Okay, so we kept this one a little short. Isn't that nice?